Okay, so this is the experiment on ideal gas law. What you have here is a syringe that's from 0 to 60 milliliters. We have a temperature sensor and a pressure sensor. So first part of the experiment, what you need to do is you need to connect this to the temperature sensor like this, and then you're going to make sure during the experiment you don't hold the syringe like this because you're adding temperature to it. You're going to press plunger all the way down and read the value on the syringe, and this is 20 centimeters cubed. Centimeters cubed corresponds to milliliters. You're going to write down that volume, that is the volume, the minimum. Okay, so then you're going to log into the student account and open experiment 12, ideal gas law. You have here temperature, pressure as a function of time. So in the next part of the experiment, we are going to connect the pressure sensor here, like this. And then before you connect the pressure sensor, actually, you're going to pull this plunger all the way up to 50. Then you're going to connect, make sure it snaps, and then lab partner is going to press start, and then you're going to really fast press this down, wait for a couple of the seconds until pressure stabilizes, and then you're going to release it and let it go. Once the pressure stabilizes, you're going to stop recording. Okay, so you see here in the first part, this is when you started recording. You pressed the plunger, and then you waited for the pressure to stabilize, and then you released. So you see how pressure increased, stabilized, and then decreased because the volume increased. And then also for the temperature, when you press, because the pressure increased and the volume decreased, temperature increased, then it started going down to stabilize, and then when you released, it dropped down back again. Before you started doing this, you were supposed to record the temperature in the room, and that number is going to be, you just press start and record, and that number is going to be around the room temperature. And you can see here that number is around 26 degrees Celsius. Okay, I'm going to stop this because the temperature is not changing. Okay, so then what do you need to do is you need to analyze your data. So you know that your initial pressure volume on the plunger, when you released it, it didn't go all the way back. So your initial volume on the plunger was 50 centimeters cubed, and then your final volume, V2, was 20 centimeters cubed. Then you are going to record the temperature after it's stabilized. So what you're going to do, you're going to click on the graph here, select this run, and then you can highlight the data simply by dragging here and seeing when you are at a volume of 20 centimeters cubed here, you can see that your temperature is going to be around 31 degrees Celsius. I will send you this data so you will be able to see clearly. Okay, so then you're going to highlight the area on the pressure graph at the beginning of the run before we compress the air. So you're going to go to the pressure graph here, highlight before we compressed, and that's my initial pressure, and it is a standard pressure, 101.4 kilopascals. So that's my P1, and my V1 was 20 centimeters cubed. Then we are going to highlight the area on the pressure just before the plunger was released. So that's this one here, and you see because the volume now is 20 centimeters cubed and the pressure is going to be much higher, is going to be around 238.6 for this particular experiment. Then you're going to write down these values for the volume and pressure in your table, and then you're going to calculate the values for T1 and T2, and then compare them. Okay, so then you're going to compare the ratio of V1 to V2 and P2 to P1 and calculate the difference. And you're going to see that you're going to have the larger percent difference between these two. The reason for that is because my initial volume is not going to be only 50 centimeters cubed. We have some air in this tubing here. So you're going to set up the equation for the ideal gas law and calculate this additional volume, V0, in this tubing. So then what you should remember is that your initial volume is going to be 50 centimeters cubed plus V0, and your final volume is going to be 20 centimeters cubed plus V0. You're going to calculate the V0 value, and then you're going to adjust for your volume, and then recalculate the P1 V1 over T1 and P2 V2 over T2, and see that now the percentage difference is going to be much smaller. Okay, so in the last part of the experiment, the goal is to actually calculate how many moles of the air do you have inside the cylinder here together with tubing. Okay, so what are we going to do? We are going to set the plunger to 50 centimeters cubed. First, I'm going to tell you what we're going to do, and then I'm going to do the experiment, okay? Set the plunger to 50 centimeters cubed, and then you're going to start taking the data, and then you're going to press the plunger down in increments of 5 centimeters cubed, but between each pressing down, you're going to wait until the pressure and temperature stabilize. Okay, so, no. I'm going to deselect this. Okay, so I'm gonna start recording, and then I'm gonna press to 45, and then wait. Then I'm gonna press down to 40, then wait until it becomes flat line. 35. The further down you go, the more difficult it becomes to hold this. 30. 25. And 20. Okay, that's it. I'm gonna stop recording here. So you see these stairs in the pressure. So I pressed, the pressure increased. I pressed more, the pressure increased. I pressed more, increased, and so on and so on. So what are we going to do? We are going to highlight these portions here and read the values for pressure, and then record them in a table 12.5 in your lab manual. So for the first one, when we had we're going to start from the initial one, right? Sorry, we're going to start from the initial one. When we have 50 plus V0 volume, we're going to record the pressure. Then we're going to record the pressure when we had 45 plus V0, 40 plus V0, and so on for all of the measurements until the very last one. You're going to record volume and pressure in the table, and then you're going to plot the equation PV is equal nRT and calculate the slope, and then from the slope you're going to determine the number of moles of the gas in the syringe. So that's basically that. I will send you all these graphs and all the data for the table that you need to complete this experiment. And that's all. Thank you.